Hello, a very good afternoon to all of you in India, a very good morning and a good evening to other people from other parts of the world. I am Ravindra Naik from Data Research Development and Design Center at Pune in India. Today I intend to talk about transformations. I have split my talk into three parts. Initially, I want to bring out the context of transformations. Then I would talk about the history of transformations within my organization and the community in general. And lastly, I would present my views of the future for transformations. Let's begin with what I mean by transformations. So, enterprises want to provide and sell their products and their services to their customers. And clearly, they want to provide new products over a period of time. They want to provide variations of their services to their customers. And since businesses are supported, automated by IT systems and applications, these systems and applications must undergo changes, must undergo transformations in order to support the transformation of the business. Now, the transformations of systems and applications is also for various other reasons. But let's see what are the different transformations of the software systems and applications that we understand. So, all of you must have seen, or all of you must know, the software modernization and renovation term. Primarily, converting an older system or system in an older programming language to a modern programming language, or making use of a library of the library that is built for using modern technology has been one of the categories of transformations. A second class would be the re-architecting or refactoring of an older architecture. So, the monolithic architectures always found a solace in the new multi-tiered MVC kinds of architectures. This was the other class. If none of these were possible, typically rewriting the older system on a modern platform was another way of transforming an older system. Enterprises, of course, wanted to change their business processes. They want to optimize their processes, they want to change the processes, and the changes in the systems to support such changes in the processes were also part of the transformations. In the recent times, software systems of enterprises are being replaced with commercial off-the-shelf platforms or packages, and this is another class of transformations that are coming into the picture. Of course, migrating to cloud or making changes in the system so as to make the customer as the central focal point, automating the decisions that are being made in the processes are all parts of transformations. So, in general, developing a system from scratch is a rare phenomenon. Typically, new system development starts from an existing system and which gets transformed into a new system. Well, I'm not going to discuss the challenges of transformations in detail. I just want to make a note that transforming an older system into a newer system is quite a non-trivial activity, and primarily this is because the old system must coexist with the new system during the transition, and this is because the business has to continue its operations. These complexities add a lot of difficulties for implementing the transformations. Having looked at what, let's look at why these transformations are important for the businesses. So, enterprises have invested in the past to create software systems, and so they definitely want to realize the values of those past investments. Importantly, in many cases, the knowledge of the business is actually only in the software systems. Most of the documentation, or a lot of the documentation, is obsolete, and therefore the existing systems are transformations of the existing systems is important. Secondly, enterprises want to do their business efficiently and at minimal cost. Therefore, standardization of technology stack so that the enterprises have to deal with fewer vendors, exploiting and making use of new and faster technologies, and making use of multi-tier architectures are important to reduce their costs. Enterprises see a lot of business value in automating their business processes or providing personalization or interaction for the customers. And this business value comes in because of transformations. Of critical importance in the recent past for finance, healthcare, as well as utilities enterprises has been the local regulations, security, and privacy. Now, this can be instantiated by standardizing the processes or by moving to commercial off-the-shelf packages. And these transformations thus bring in a lot of business value, a lot of saving in cost, efficiency for the enterprises. Let's look at the market of transformations. As you can see, in the next 4 to 5 years, there is a growth or anticipated growth of 10 to 12% annually for the transformations business. In spite of being such a big business of transformations, McKinsey observes that 74% of the transformation projects result in failure. Now, is there a way that we can analyze these failures, and is there a way that we can try and address these failures to convert them into successes? Let's see if there is something that we can do for these failures. In the next part, I'll try and look at the history of how transformations have been done in the past. What we see here is the late 80s or early 90s, when C programming language was becoming popular because of its simple abstractions and efficient implementation. To convert programs written in other languages to C, these kinds of tree specifications of the program and tree transformation specifications to transform the program were adequate to implement such transformations. Such declarative specifications were used to create numerous compilers and code generators. TCS itself built compilers for Pascal, Fortran, COBOL, and Chill programming language. But of particular big business value was the conversion of one language to the other language. So primarily Pascal to C, Fortran to C. COBOL to C and PL1 to C were the translators that were implemented using the tree transformation technologies. A lot of COBOL dialects were converted to MF COBOL or mainframe COBOL using the same technology. While this was being done, the community also came up with model-driven code generation. So Rational Rose and TCS both had modeling tools. Rational Rose was eventually owned by IBM, and these tools provided abstractions in the form of models. Even the code had to be written was on the top of the models, and very little code had to be written. The code generators essentially hid all the architecture specific complexities and the underlying technologies, and these code generators only had to be rewritten if there was a change in technology or a change in architecture. Now, these model driven code generation methods were used very successfully to build large-sized applications, primarily platforms. Small and mid-sized systems were not met with very little success using these technologies. The reason why I talked about code generation was its use in our re-architecting approach. So here is an example of RPG program. An RPG is a report program generator programming language on AS400 platform from IBM, which I believe is now called P-Series. Now this programming language provides capability to write down the UI, the initialization logic, the business logic, as well as the database logic. And once this monolithic application is in operation, you need no other subsystems in order to run the entire system. Because of its monolithic nature, making changes to such an application was a difficult prospect, and one idea was to re-architect it into an MVC architecture. So the idea was to convert the display files into JSP pages and split up these initialization, validation, computation, and database layers into different components. And each of these components could then be attached to the corresponding domain objects or to the persistent objects for realizing the model view controller architecture. The way we went about doing this using tools was to analyze the RPG programs and perform control flow and data flow analysis on the code. This core analysis then provided us ability to extract screens, to extract a database layout and database accesses, to identify the validations and the computation logic in the code. Having created or identified such parts in the code, the next step was to take the database layout and access and translate it into data definitions and database queries. The database layout was also used to identify the domain classes, and the validation and computation logic in its individual component form were translated into Java code. All of this was fed into our model-based code generation tools, which in turn plugged and generated the entire code using the domain classes and the persistent classes identified in the previous steps. So a combination of reverse engineering to identify components, migration or conversion to identify the domain classes, the DB queries, and the validation and computation logic, and then a forward engineering approach to generate all the rest of the code, resulted in converting a monolithic RPG application into an MVC J2EE architecture. While this involved a top-down analysis using structured program information, it also involved a bottom-up analysis using critical data items and taking slices of these data items in the backwards direction. As a side effect of this, what we were able to create were the business rules. So for critical data items, by using data slicing and program slicing and decorating the slices or expressing the slices using business terms helped us identify business rules, and this became an important component of the business knowledge that we were able to extract from the code. Elsewhere in the community, dynamic analysis was also used for reverse engineering, where the dynamic analysis analyzed the logs and traces of the application to identify processes. What were the challenges and learnings from this exercise? One thing was the conversion techniques worked very well when the paradigms of the source and target were similar. In the case of re-architecting, the combination of reverse engineering, transformation, and code generation tools did provide a good solution. However, the knowledge of business domain was not really utilized in the re-architecting approach. The reverse engineering had its own perils because of the static data flow and control flow analysis, which had numerous false positives due to the precision issues. If the service code was intertwined and tangled, then it was extremely hard for tools to unweave it. For such validation and computation services, the programmers and the analysts had to rewrite the programs manually. To address this, we did come up with a refactoring workbench which helped reduce or eliminate the technical debt before the re-architecting was done. However, such a refactoring did not provide a viable business proposition by itself, since the enterprises saw a value in transformations and re-architecting, but not much value in removing or eliminating the technical debt. So overall, the end-to-end semi-automated transformation met with limited success, primarily because of two reasons. One thing, the target was a MVC architecture, but the code of the target had a flavor of the source. Secondly, the domain classes in the target were a replica of the source data model and did not really use the knowledge of the domain to identify more appropriate domain classes. A silver lining, however, of this semi-automated approach was the business rule extraction techniques. This has been a big business success in my organization, and though it is human assisted and it has false positives, it has provided immense value to mining of business rules from applications. However, this part does provide extraction of just one aspect. So what are the remaining aspects? What do we need to do in the future? Now, if you look at some studies done by McKinsey and Deloitte, of particular importance is that enterprises are not looking at incremental transformations, but they want to see transformations that provide them big value, and not just today, but even in the future. So they want to transform to systems that can be evolved in the future, systems that can exploit the technology landscape in the future as well. J.D. Meyer makes a specific observation that the business strategy needs to be linked to the transformation, and enterprises want to see faster time to market and product pipeline growth using the transformed system, and therefore there must be a linkage between the two. And for this to happen, we must be able to identify the business capabilities that are of importance. If you look at the digital transformations, the automation of processes is at the top of the stack, and this automation could be assisted using data-driven analytics. Cloud migration is clearly an important aspect of digital transformation, but enterprises are very careful in wanting to have configurable software systems. So they want the new software systems to be configurable in terms of the business products that they want to offer. All of these essentially underline the importance of capturing business and domain knowledge, digitizing such a business and domain knowledge. My take on digitizing such a business or domain knowledge is to be able to create the building blocks of the business capabilities and the business domain. Now, what are these building blocks? All of us know the notion of business products. All of us know the notion of business services and processes. While these constitute the basic building blocks of the business capability, we must be able to express the business products and business processes in terms of business facts and business rules. So what are business facts and rules? Facts themselves are propositions over business terms, while rules are constraints over the business terms. In general, the proposal is that we want to be able to create the business vocabulary and then build or define business products and business processes making use of this business vocabulary by using the intermediate concepts of constraints and propositions. This is a schematic of how this could happen. So the business products will be a composition of rules and facts which in turn make use of business terms. Similarly, processes are the sequences of the business rules, while functional modules implement the business processes and services which in turn provide the business products as value adds to the customers. In order to having created such a digitized business repository, what is it that we can do? What are the use cases of creating such a business domain and business or domain knowledge? One important use case is the ability to configure the software platforms or software packages. The configuration typically is of the business products that the package or platform provides. So the products expressed in terms of rules and facts becomes the primary driver for being able to configure a business product or package. The business processes and services expressed in terms of rules becomes the primary element to identify microservices for the cloud. The business rules and business facts themselves could be externalized using business rule engines. So these are some of the use cases, while there are numerous other use cases that will be enabled if we are able to digitize such a business knowledge. Now, authoring or creating such a digitized business knowledge is also a non-trivial activity. So we'll need a lot of research in terms of mining the business rules from source code, identifying and creating processes using dynamic analysis of the logs and traces of a running system. The data model would essentially provide the initial impetus for the business terms, but this will need to be refined using domain knowledge expertise, while the documents or the plan requirements will provide one source of capturing all the business products that are on offer. So there are various buckets of research challenges that need to be addressed to make this schematic a real realization. So the statement I am making over here is that we want to move from just re-architecting the applications at a technology level to redesigning the applications based on the business domain knowledge, and this business domain knowledge must be captured in a digitized form. So the takeaways of my talk: transformations are seamlessly integrating into the development. Okay, they are no longer a standalone activity, and the development itself is being driven by business and domain knowledge in a digitized form. So even earlier we were doing requirements and requirements analysis for design documents or for user stories, but now the digitized business and domain knowledge can become a critical driving factor and provide a critical bridge to the business objectives. The development methods, in order to make use of this digitized business and domain knowledge, would need to make reverse engineering as part and parcel of their own methods. These are the key points that I think are important for the new generation of transformations. These are some of the references that I have used, including the TCS internal notes and technical publications. With that, I come to the end of my talk and would be willing to take questions.